I'm Blaine Hoshizaki, and I'm the director of the Neurotrauma Impact Science Lab at the University of Ottawa. Our research here really is connecting brain trauma with brain injury. Our lab primarily focuses on sport injury and its relationship to brain trauma. Certainly for the last 15 or 20 years, the brain trauma or concussions have been a big topic in professional sports. However, one of our real concerns is with youth sport, because at the youth level there's vastly more people participating, and it may have a more influential effect on their life health, their mental health over a lifetime. And of course this is very concerning for us, or very interesting for us, and we'd like to better understand that. Because we're experts in reconstruction, there are a lot of other partnerships we have with the University of Dublin, UCD in Dublin, also with Harvard University and University of Toronto, and the hospitals as well, the Ottawa Hospital, CHEO, the Hull Hospital, as well as the hospital in Toronto. So we create these relationships primarily because our expertise is very focused, as most scientific labs are, and these other universities, research programs, bring other expertise that we join with to answer bigger problems. So we're getting a much better understanding of what creates the risk for concussion, and what sorts of impacts and what sorts of trauma are associated with concussion. And now we're starting to get an understanding, of just beginning to understand the relationship between trauma in general in a sport and how it associates with neurological disorders later in life. This lab is a biomechanics lab, and it involves not just understanding the mechanics or the engineering piece, but in addition you have to understand the sport, because you cannot analyze the sport without fully understanding it. So people involved in this lab are a combination of people with engineering background, people with a sport background, and people with clinical, because of course the outcomes are important to understand in terms of predicting what creates those outcomes. We all work together to address these problems. We spent a lot of time developing not just better understanding trauma and injury, but also looking at ways to mitigate that risk. So we get a chance to work in helmets, as you can see behind me, in terms of innovation and creating safer helmets and creating safer standards. We're involved in the standards organizations worldwide. We're involved in developing technology for helmet companies. So we're really taking our knowledge that we're learning in this lab and we're transferring it into the field, so that has a real effect. And I think that's exciting for myself as well as the students. Sport is really, I think, something that enriches people's lives, and a lot of people involved in it, and it's exciting. And of course professional sports adds another dimension to it. And the other elements is to take our science and create differences in the world is very, very important. And that's what's exciting, one of the most exciting things about being involved in this lab.
My name is Andrew Post. I'm a postdoctoral fellow here at the Neurotrauma Impact Science Laboratory. I work heavily in conjunction with St. Michael's Hospital under Dr. Cusimano. The work I do is specifically looking at the relationship between biomechanics and brain imaging. So more specifically, I look at how you get hit in the head and how it reflects in actual brain tissue damage inside the brain itself. The problem that we have these days with concussion is that it's a symptomology-based problem. So when you get hit, you end up with a symptom such as a headache or amnesia or a variety of factors which may not actually be related to the actual brain tissue damage itself. It could be related to a neck injury or an inner ear problem or something like that. So what we're trying to figure out is exactly how somebody gets hit. It's on the field of play, for example in sport, or out there if you slip on the ice and hit your head, and how that relates to actual damage that we can measure quantitatively inside the brain tissue. And that's where the collaboration with St. Michael's Hospital is really important, and it's almost groundbreaking in its scope, really. I was always very interested in biomechanics, so the relationship between the mechanical event and tissue, and specifically brain injury, but more injury as a whole. So when I started off in my undergrad, I was interested in biomechanics and physiology specifically, and not so much the other areas of kinesiology. So when I had the opportunity to work with Blaine out of my master's and help develop this laboratory, it was a really good opportunity to get into product development and relate that to how do you prevent injury as well. So an understanding of how injury happens and then bring it through to product was something I was really interested in. And then it developed into my PhD, which is injury mechanics, and then now my postdocs. So I've been here for 10 years now. I've been here the longest out of everybody. Blaine hired me to help develop the lab, and it's grown into this amazing unit where a lot of really smart people doing some really amazing work. So it's been really rewarding for me to see things coming through from just me working in the corner of a basement to all of this.
My name is Jenny Cronoyer. I'm a PhD student here. I come from a different background than most students here. I'm a little more clinical because I'm an athletic therapist. As such, my research interests are a little more clinical as well. So what I'm looking at is what can cause loss of consciousness in sports concussion. So I'm going to look at the brain tissue deformation, the magnitudes, and also where in the brain it occurs, to try to see what happens in the brain when somebody gets knocked out from an impact. I got into this research here because when I was on the field, I always had to argue with coaches trying to explain that concussions are dangerous. And basically the answer of the coach was like, there's not that much research, and I got tired of hearing that, so I decided to come do the research for myself. As for why the topic of LOC is because I'm very interested in how the symptoms of concussion are so diverse in terms of clinical variability, but LOC as a sign of concussions is something that we can see. It's not something that a person say they feel, as opposed to saying, oh, I have a headache or dizziness. So in terms of using our tools here to research the link between the injury and the outcome, it's easier to start with something that's objective, like loss of consciousness. I wanted to improve the quality of knowledge on concussion so that it can guide a little bit more how to prevent it in the field, and to know a little bit more of what constitutes a more severe impact.
My name is Clara Carton. I'm a doctorate student here at the University of Ottawa in the Neurotrauma Impact Science Lab. I'm really interested in understanding brain trauma from maybe more of a holistic approach, so one that considers all the characteristics of multiple events. So there's really a growing body of research that is showing how biomechanical forces are causing metabolic, physiological, as well as cellular changes in the absence of what we would consider or recognize as an injury. And these have cumulative effects on our mental health. So not only are these reporting how hard somebody gets hit, but there's an interaction with various other characteristics. So how many times someone gets hit, the time interval between impacts, as well as the duration of the exposure to trauma, so over a game versus a season and a career. And really all of these characteristics combine to define what I would consider a trauma load or a trauma profile, and this is what my research really aims to measure. Early on, I really experienced a lot of the benefits and enjoyments of growing up playing team sport, and I think that was really the driving force for pursuing my academics in human kinetics. So I think this really gave me a platform to research and to examine team sport in the context of brain health. Later on, I became quite familiar with mental illness and brain damage and brain disease, both in the form of psychiatric disorder as well as chronic injury, so one that would develop over time leading to neurodegenerative disorders and diseases. And I also worked with adults with developmental disabilities during my undergraduate degree. So all of this really piqued an interest and a curiosity into how the brain works and is influenced by both genetics and various environments. We know that there is always some inherent risk when we participate in sport, especially contact sport. But my hope really is that we can establish some context around what a reasonable amount of risk is versus when the amount of trauma to our brain becomes detrimental to mental health. By profiling sport and athletes, we can shed some light into the cumulative effects of trauma. So really hoping to foster all the benefits that we have from physical activity, team sports, but by mitigating the risk to developing any type of mental illness.
My name is Talia Ignacy. I'm a research assistant here at the Neurotrauma Impact Science Lab at the University of Ottawa. And I also recently completed the Master of Science program, completing my master's thesis in this lab as well. So the focus of my research was comparing the common injury events causing concussion in professional men's rugby league. So it's commonly known that players are obtaining concussive injury from shoulder to head to head, hip to head, and knee to head impacts. And the focus of my research was comparing these injury events to kind of obtain a comparison of risk. So the results of the study were that we saw that the head-to-head and the knee-to-head impacts produced the largest values of dynamic response, and they were approaching levels where you'd actually expect to see traumatic brain injury, so much more severe than concussion. And there were no differences between the hip-to-head concussive impacts. And so this is kind of a starting point, or this is a first point where they can start to create interventions to reduce the incidence of concussive injury in rugby. Well, I think that contact is inherent to the sport, but I think that there are ways that we can mitigate that risk. For instance, a lot of the shoulder-to-head impacts are occurring illegally, and players are not being penalized. So one of the outcomes of this study could be more stringent enforcement of the rules on behalf of the referees to reduce incidence of those types of concussive injuries. Research in terms of concussions in rugby is fairly new from a biomechanics standpoint, so we know how players are obtaining concussive injury, but we don't understand how that relates to risk. And so the outcomes of this research kind of informs to how risk is created in these types of injuries.
My name is Karen Taylor. I'm a fourth year PhD student here. I have a background in athletic therapy and mechanical engineering. So my PhD thesis is looking at energy transfer into the brain and trying to reduce that through helmet innovation. And the way we're looking at doing that is current helmets actually try to reduce the energy transferred into the brain upon impact by linear attenuation. And current helmets actually do a pretty good job of doing that through a helmet, the combined helmet shell and the liner itself. And the way that they reduce the energy is through material deformation. But they've shown that this works well at reducing injuries such as traumatic brain injuries, skull fractures, things like that. But we're still seeing an incidence of concussion. And so they believe that the amount of energy being transferred into the brain is still sufficient enough to cause concussive injury, as well as it's due to a rotational component of the brain. So what I'm trying to look at is actually using helmet innovation to try and further reduce the energy transferred into the brain and reduce the rotational acceleration. We're going to do that by redirecting or redistributing the energy force. I did initially play sports in university, and then I was taking athletic therapy, and I decided that I wanted to get into more of the mechanics of the body and biomechanics, stuff like that. And so I went back to university and did mechanical engineering and did a master's in a biomed field. There wasn't biomed engineering at the time at the university, so I did it in mechanical engineering. Took a bit of a break and then decided to combine it all and come back and do my PhD in biomechanics.